That's so cool.
It's okay.
It's going to be amazing. Yes. It's going to be amazing.
That's probably enough drinks for tonight.
That's so cool. It's going to be amazing. It's going to be amazing.
That's probably enough drinks for tonight.
That's so cool.
It's okay. It's okay.
That's so cool.
That's probably enough drinks for tonight.
That's so cool.
It's okay.
It's going to be amazing.
It's okay.
That's so cool.
That's probably enough drinks for tonight. Hello, everyone. Thank you for joining us today at our live stream. I'm Mario Garcia. I'm a technical evangelist here at Percona. And today we have Marcos Alve, principal support engineer. And the topic for today is how to benchmark your MySQL database. Thanks, Marcos, for joining us today.
Yes, sir. My pleasure. And yeah, I'm going to be talking a bit more about how to think about benchmarks in general, and then a little bit about the MySQL part. So let me share my screen. I always forget how you do this here. I don't use Restream so often. Let me share, and then can you see my slides?
Yeah,
All right, then let's start. So, welcome everybody. Again, I'm going to be focusing more on how to think about benchmarks, and then we're going to see some of the actual commands, and I will show you some I've done in the past. So, let's see. What is a benchmark? Well, according to the New Hackers Dictionary, also known as the jargon file, it's an inaccurate measure of computer performance. And so I started with this as an intro because I want you to be aware that benchmarks can be very, very misleading. Very misleading. Um, and there are two ways they can be misleading. Either they were prepared and executed and presented by someone who didn't have the technical expertise to properly design and interpret the results of a benchmark, or because someone in the marketing department thought it was better to, you know, create a benchmark that favored your product versus the competence. So, again, always take benchmarks with a big pinch of salt, and also, distrust your own benchmarks. Like, you have to be critical of your own benchmarks and make sure you're, testing the right things and looking at the right things. That's why I wanted to start with this, because it's very common to see benchmarks that are shenanigans. All right, so with that in out of the way, let's start. I'm going to talk why do we benchmark, what is that we actually do the benchmark on. We're going to tell things that we should keep in mind when doing benchmarks, and we're going to talk about things we should avoid when doing benchmarks. We're going to see how actually what types of benchmarks there are and how they are done, and then like one or two examples that I have around that I think are worthy. So why do we embark on spending time on something like benchmarking? Well, marketing, of course, like it's a valid reason, and when done properly, it's not horrible. But to say, okay, uh, MySQL is faster than Postgres, or Postgres is faster than Oracle, whatever. There is always the price involved. You have to include pricing in your benchmarks. Like, if I will compare cloud instances, pricing will be a very big factor. So I will not only talk about the raw performance, but I will certainly talk about the cost of things. We also perform benchmark to understand the effect of tuning. So when I tune something, or if I upgrade my MySQL, if I upgrade my OS, if I change a setting in my OS, does it change anything? Is it positive? Does it have a positive impact, or is it a negative impact? So understanding the differences of our future operations, again, upgrades, tuning, etc., it's one of the big reasons to do benchmarking. Also for scalability, when we want to understand the limits of our hardware, the limits of our software, and we want to perform so-called capacity planning, then benchmarking will certainly help us. It is probably one of the difficulties, the most difficult type of benchmarks, because for proper capacity planning and for proper scalability analysis, you really have to have a very good benchmark that is close to your production application. So, if the benchmark I run is nothing like my production, then it's hard to actually make any sense out of the results. Even if I do everything proper, if it's not like a good equivalent of my production workload, then the benchmark is going to be meaningless. Verification. And with this, what we're trying to say is, let's imagine I'm suffering some performance issue, and I want to make sure my disk is in good shape, or my network is in good shape, or that my memory, it's okay, that it's providing me the adequate response times and throughput. So sometimes you run your software and you are not sure if it's the software or the resources that are suffering performance degradation. So benchmarking the resources, it's a very good way to understand that. And also benchmarking your software on a different set of resources, so on a separate machine, it's also a good way to understand and troubleshoot. So troubleshooting, it's another good reason. Reliability. This is something few teams do, I guess, but it's so useful. And it's basically when you're going to release your next application version, part of your testing should be a benchmark of your application. It should be a real replay, or a real simulation of your application. And those simulations, even when they're not going to be identical to the production workload, they're at least going to be identical among themselves. So I can always compare with the previous iteration of that testing. And so I can say, okay, this version of my libraries is still as good as the previous version of my libraries. And I will, have a good understanding of whether there are regression in performance or not, or if, at least I'm going to discard the obvious issues. There's always the chance that, once you're in production, things are going to be somewhat different. But having a base reference, it's, I would say, important and very desirable. And, also for fun and curiosity, like, what does this do? And, if you are actually in that group of people that you like to do benchmarks for fun, you can email me. We have a job for you. Just let us know. And then we're going to talk about what exactly is that we're going to be benchmarking. Benchmark, aside of the funny definition I tried to give when we started, it's on your workbench. When you're a carpenter, you have marks on your bench that help you very quickly measure the length of a piece of wood. And this is where the word comes from. And actually, the meaning is compare, right? Like, benchmark is let's compare. So what we benchmark is, what we compare is the performance of the two things that exist in computer, basically, which are resources and software, so hardware and software. And we're always going to be testing those very much. That is the focus, and basically the only thing I can think you could benchmark. Again, there is always the cost. So, the relationship between performance and cost is part of a benchmark. For sure, you should always consider that. Um, there are stories of vendors that make, not false claims because the benchmark is correct, but they never tell you they spent $1 million in hardware to get those results. And they showcase those results as a generic, thing that will be running on whatever hardware most people have. But in the end, it's going to be, only true in the $1 million hardware. So cost, hardware, and software are the things we are going to be measuring. So the resources, CPU, file, memory, and also when I say resources, there are things like buffers or threads or mutexes, things that are facilities or things that every piece of software will use. Again, the pthreads subsystem in Linux is something every piece of software around there, or at least multi-threaded software, will use. So understanding if the pthreads implementation in my OS is more reliable or more responsive than other implementation is interesting. Mutexes are the same, like the fast mutex implementation. Is it better on this OS or on this other? Those are also called resources in our world. And then the code, which is my own code, like the code I wrote that will use file, CPU, memory, threads, mutexes, etc. So what else? Let's talk about a bit about what should we do and what should we do not. And here are the key things I believe should be in every benchmark that wants to be successful in terms of providing useful, meaningful results. So first of all, you have to make it repeatable and script it. Make it a script and collect the details and put them in a way anybody can go ahead and recreate that benchmark. That is really important. I think that's the most important piece. Like, I want to repeat this benchmark. Next time I have a new piece of hardware, next time I have a new library version, next time I have a new version of my software. So repeating, being able to easily repeat the benchmark is crucial. Then, of course, observe it. You run a benchmark and you don't collect data, you did nothing. Like, you just spent a lot of electricity, burning CPU time. But what is the result? So to actually make useful benchmarks, we need to set up proper and consistent monitoring across all the benchmarks we run. And if I run different benchmarks to measure the same thing, I should always monitor the same metrics and try to present the same results. So monitoring with something like, could be PMM, or it could be SAR, or it could be, anything you have that will collect metrics about the OS performance. This is the resources, and that it will also collect metrics about the software. For example, in MySQL, I will try to collect, if I didn't have PMM, I will collect show global status samples. I will collect show engine InnoDB status. I will sample the performance schema for mutexes information. And, I will just, in general, gather metrics on a time sampled basis so I can later understand the effect of the different settings or hardware or versions. Again, related to scripting it, you have to make it easy to rerun. Like, if I have to spend 30 minutes of my own time preparing the benchmark, it's going to be a very unpopular benchmark among your peers. Ideally, it should really be like a single script with a configuration file or a few parameters that we can quickly type in and say, okay, this is what we need. Just run it. And I can turn around, let it run for a couple of hours, come back and see the results. So, that's an important part, is make it easy to rerun. Another crucial bit, and this is really important, is test one thing at a time. Don't change 20 variables and do another benchmark, then change another 10 variables and do another benchmark. Change one variable, test it, change another variable, test it. So you can understand the individual effect of things. Otherwise, it's going to be very confusing, and it's going to be super hard to reach conclusions as of what produces what effect. Benchmarking is hard. It's a long, cumbersome road, and perhaps you need to test the same things even in different order to really understand what is going on. But if you test more than one thing at a time, you're never going to find out what happened. Then be realistic. Try to make the benchmark so that is to some extent comparable with your target load. Or again, if I want to benchmark for my DB, and I benchmark on the most expensive EC2 instance, and then I will be running on an instance that is 1/10 of the size. Well, I won't have the same results. So I need to be realistic and choose the right instance type. And do I expect to have 20,000 customers? And how many application servers? Well, I will try to dimension the clients for the benchmark similar to the numbers we project for threads coming from the application servers and the clients. So trying to not over-dimension or under-dimension things, or use different resources than what we expect to use in our end case, in our real production use case. Then sanity checks. This is somewhat related to being realistic. Is like in my benchmark, I see numbers that exceed the capacity of my storage, for example. I know my storage can do 1,000 IOPS of 16 kilobytes per second of random read writes, and I see 5,000. It's like something is wrong. Like that number is wrong, and the likely reason is I am hitting some cache, and so I'm not testing the IO, I'm testing the cache. So sanity checks help us, avoid lying to ourselves. Again, it's a way to not fall into your own trap. I've seen this dozens of times precisely with that example. People trying to test their IO and thinking they were testing their IO when in fact they were testing the file system cache that Linux puts in front of the IO. And sure, they were doing like 10,000 IOPS, but in reality, they were doing only, 20 IOPS, and the rest were hitting the cache. As soon as we disabled the cache, they were able to see the real numbers, and then those real numbers verified the problem we were telling them the customer had. So this is really important. And then again, as you observe the data and gather all this, and you have fancy graphs, that's all fine and dandy, but then we have to reach conclusions. And it's important that when we set to do a benchmark, we have goals, I guess. I should have put that here as well. Have clear goals of what you're testing, and avoid trying to have expectations. So my goal is to understand the different performance of memory allocators, but I will have blank expectations about that. I will not set myself to say, oh, I believe jmalloc should be better, or tcmalloc is gonna cause more fragmentation. No, I rather will say, okay, I'm gonna test and I'm going to analyze the allocations with different block size, and I'm gonna see how they behave with reads, see how they behave when I do sequential writes, and then I'm going to compare those and arrive to some conclusions. So arriving to conclusions based on the data you collected is important, and it's a holistic part of benchmarking, and it's probably the most difficult part of benchmarking because it requires deeper expertise on the software or the resources you are benchmarking. So if you don't truly understand how MySQL works, you're going to see something, a variable change. You're going to say, okay, I'm going to enable the query cache, bam, and I will run a few benchmarks, and when I see the results, it's going to be hard to interpret. Like, why does the query cache show so very good results for reads when it's running on one or two threads, and then it doesn't work for the 200 threads? So that type of conclusions, like understanding that, requires investigation and requires understanding of the system you're benchmarking. So if it's your own application, it's easier. If it's a big application like MySQL, might be harder. Finally, present it, or not finally, but present it. Once you have those conclusions, you should present them in a way that they are clear, the methodology is clear, the objective of the benchmark is clear, and the results are clear and easy to interpret by anyone. And finally, of course, share it. Again, you already have a script, you have your presentation. It makes for a great blog post. Go ahead and share it. So not only others can benefit from it, but also others can do independent verifications of your own benchmarks. Like, is the benchmark I wrote reasonable, or do I have some mistake? And sharing with the community, especially in the open source community, is going to give you answers. People is eager to take a look and is eager to try on their side. So this is also, again, especially in our open source world, it's a crucial part of benchmarking, I believe, to have independent verifications. It makes it look more like science and all. All right, and these are the big do's of benchmarking. Let's go with the don'ts. Oh, sorry, no, one more thing. I'm going to show you an example of how, when I say test one thing at a time, like a very basic idea, and I think we will have time to do a demo of this in a moment. But basically, when I want to test one thing at a time, what I will do is, I will create a loop like this, where I have the variables I want to change in my benchmark, and I will set the different values for those variables. For example, here I'm going to test this benchmark. I'm going to run it 7 times with different thread counts: 1, 4, 8, 16, 32, etc. And each of those is going to run for a different number of tables, because I want to exercise the mutexes, and I also want to exercise the dictionary, the data dictionary. So I'm going to test with 1, 10, 100, 1,000, and 10,000. And then I'm also want to test with different IO schedulers. And so some stuff is from the database, other stuff is from the clients, and other stuff is from the OS. So I'm, changing things from 3 different places, but I'm changing things one at a time, because all these tests, the combination of all these tests is gonna, in the end, I'm gonna have 105 results for this. I'm gonna have 7 times 5 is 35, times 3 is 105. So I'm gonna do 105 different benchmarks that and each is going to be all the possible combinations of those, which again is going to allow me to test one thing at a time. And again, what I will just set those variables in these loops, and then I will just use them in the body of my test. I will just finally use these variables. I use scheduler, I will set the queue scheduler. Then I will take tables and I will set, for example, for sysbench, if instead of my test, I will use sysbench, I will use threads and tables. And I will also have a neatly organized results folder. In this case, I decided, okay, I'm going to categorize my testing on the schedulers, because that's my main target for this benchmark was the schedulers. And then I put my test name, the name of the test I'm running, and I'm saying threads. And then I will here, it's off the screen, I'm sorry. But basically, I also have the tables variable after that $sign. So then I'm going to have 105 of these files, and I can extract data from there, and I can create plots and graphs and summaries and averages and anything I want to help me understand the results and arrive to conclusions. Again, beware of the number of results. This simple one, this is a very simple benchmark, is giving you over 100 results. It's going to take you time to go through that stuff. And the right thing to do is have some scripts that help you extract the data from all those results and to help you present it. So scripts that automate the initial presentations for your analysis. That's important to have as well. Usually it's just, grep extracting averages, percentiles, and totals, so you can present those in graphs. And with the plotting, you can say, oh, look, like this and that. All right, let's...
Marcos. Yeah. There's a question. If there's a way to keep the database running when doing a major version upgrade.
If there's a way to keep the database running
when doing a major version upgrade, for example, when upgrading MySQL.
Oh, but you mean you want to do so you want to view to keep your database up and running while doing a benchmark? Yes.
Yeah, that's the question.
Yes, you can. There is a way to do that. I will mention it. We'll see it in a minute. I don't have a demo of it, but we have good blog post in our blog about that subject. It's absolutely possible. And I see Maxim Larin is here. Hello, Maxim. Pleased to see you here, man. Total honor. Okay. Again, here, I'm just showing you things you shouldn't do. So this is things we should avoid, and that if you do this, you're not gonna have a good benchmark, or you're gonna not be very popular in the open source community. The first one, and it's common, it's something, we are humans and we have tendencies to satisfy ourselves. So sometimes we try to specialize, or we introduce a bias in our benchmark. If I have a very fast hard drive that does, I don't know, 2x the speed of sequential reads, um, I will try to create a benchmark that is all about sequential reads. But in reality, reality is that most people suffer with random reads, and that most databases will do random reads and not sequential reads. So creating a benchmark that purposefully focuses only on sequential, it's actually a bias. And sure, it might be technically correct, but it's meaningless for the larger audience, and is not really going to result in a positive experience. If I try to use your hard drives, continue with the example, if I use those hard drives and I put them on my database, I'm not going to finally have a positive experience. So not a good idea. The other one is during the benchmark, you might see errors, I don't know, you depleted your file handlers. You will see too many files open, or too many connections, or you will see the disk full. Ignoring those, it's a bad idea. And you should always work to understand why you have errors. And then the other one is outliers. Like, why do I have like 10% of my load that returns in 10 nanoseconds, and then 80% of my load returns in like 1.5 milliseconds, and then another 10% of my load runs in like 1 second? Well, those outliers, the small ones and the big ones, it's important to seek an understanding of what mechanisms are behind them. Like, is it because I'm hitting a cache? Is it because there's another workload disturbing my benchmark? Is it because a buffer fills up and I am not properly configuring things to match a realistic environment? In any case, we need to look for the outliers, and for things that are way under, let's say, the 5 percentile and way over the 95th percentile. Why? Like, try to see why. And of course, try to not test the wrong thing. So if I'm running Sysbench for testing I/O, I need to make sure I create a data set that is large enough that is not going to fit in memory, because otherwise I'm not testing the I/O. I'm just testing the memory and the CPU. And at the same time, if you only want to test the I/O, you should probably try to reduce the things in MySQL that will prevent the I/O from being saturated, because we do want to reach saturation points. Not immediately. We want to ramp up towards saturation, but we want to reach saturation. So, like, I don't know, I will say, don't set a thread concurrency limit on MySQL, or perhaps, if you see that concurrency is so heavy that it's causing mutex contention, then do set some thread concurrency to avoid the mutexes being a problem. Or things that will reduce, like, if I want to test I/O, I will try to set full durability for MySQL instead of relaxing durability, which will avoid the most expensive fsync calls. So again, try to design and think out your benchmark in a way that reflects the reality of production as close as you can. Okay, types of benchmark. This is just a very simple list. Is basically the the micro benchmarking things, like synthetic benchmark, things that have some inspiration in a generic reality, but that they don't necessarily match the reality of your database workload. These are synthetic, and these are the least similar to your production. You know, so for this we have tools like Sysbench, MySQL Slab, and all the TPC suite, and these are easy to run, easy to configure. Like, you can just run a loop like the one I showed you earlier, and with that you will have a reasonable idea. Super useful to compare things like hardware or OS settings, like, because the test should be the same everywhere. And I can say, okay, this hardware was better for this test, and that's gonna be realistic for that test. So they are not useless, but they are very far away from being realistic. So this is to understand individual components of a system and the difference in tuning single components. Then simulation, that will be something you write. This is usually done with custom scripts. We have people that has APIs to access their database, and they will create a sequence of API requests that closely match what production looks like. So this is actually really nice. Is basically you first monitor your true production database, and you will categorize is not the word. You will try to understand how your load is composed. Like, is it mostly inserts, mostly deletes, what type of queries? And with those, characterization, that is the word. So you will characterize your workload. And again, if you have an API, you will say, okay, during the regular normal workload in my website or in my site is I hit this API endpoint 1,000 times per second, this other endpoint 25 times per second, this other endpoint 500 times per second. And so I will create a benchmark that will do that. It will hit A 1,000 times per second, B 25, and C 500. And that will be a fairly reasonable emulation of production workload. And that's actually much more helpful to help you understand your reality, the reality of your application. And then we have like direct replay for web servers, and I guess for Mongo as well. I don't remember truly, but we're talking about MySQL. You could do TCP, capture and replay. In MySQL, it's not so easy to do TCP replay as far as I know. So what we do is we capture everything in the slow query log, and then we use query playback. So query playback, it's in our Percona lab GitHub repository. I can post the link later, but basically that the tool, will try to replay the queries in the same order they arrive at, with the same rate they arrive at, and they're going to be exactly all the same queries you got in production. So it could be pretty close to reality. Depends, when you're then replaying on a different configuration, it's going to happen that queries are not going to replay exactly at the same speed. So they won't overlap the same way, and there could be very different effects on locking contention and everything. But it's a pretty good testing. And then production. And here we come to the IT viewer question. And how do you test in production? Well, you could, say, okay, if I have a couple of hours at night, I can run read-only benchmarks. I can actually use sysbench to test the individual memory and the individual CPU, file IO components of my production environment. But testing realistic workload on your production machine is not 100% possible, because that will include writes, and those writes will be destructive for your data. So I don't think you want to do that. Rather, what we have is proxy SQL mirroring. And with enough resources, with a big enough proxy SQL, mirroring will result in a very decent testing. Basically, this goes like you have your clients and you have your proxy, and the proxy is going to send the queries to both the production and the testing, the benchmarking instance. And you're going to have exactly the same traffic on both. And again, that's as close as you can get to being realistic without actually, changing parameters in your production database live. This allows you to have two identical machines, same versions, or different versions if you want to test versions, or different machines if you want to test hardware. But again, it allows you to have one additional instance that is going to get the same traffic with the exact same arrival rate. And that is really the best testing we can probably do with MySQL. It's expensive in a sense, because you need to have a rather beefy proxy SQL machine. But, it's worth the effort and the cost, because it will allow you to test very nicely. And again, you can test different hardware, different versions, different settings, and have PMM monitoring that testing instance. And, it's really useful. Like if you're proficient with data analysis, that can help you bring your actual real instance up, improve the performance in your real instance a lot, because you could do a lot of experimentation and verify that things are running better on the mirroring instance. And finally, how? No, sorry, that was that. So finally, let me show you a quick benchmark I did some time ago. I was bound to present this someday, and I never have enough time. Basically, when NVMe cards, when SSD cards were introduced, we changed one piece of the I/O stack for a new one. And with this, Linux introduced a bunch of new so-called I/O scheduler. And we were bound to give it a try, give the schedulers a try. So, basically, here is my basic presentation of the benchmarks we did back then. So I present the hardware. So if you want to verify, you will try to get similar hardware to what I used to make sure, we are doing equivalent testing. For whatever reason, I failed to keep the configuration. I must have the configuration in a folder. I couldn't find it, so I apologize. Basically, here I should present the MySQL configuration I had in use back then. And then I present the very simple script I use it for the benchmark. I have some settings I will adjust. And then I showed you before, I will have my variables. I have my variable IO scheduler, I have my variable sysbench threads. So I want to see how my goal is to see how the IO schedulers react to different levels of concurrency. That is the goal of this benchmark. So I iterate over these 4 type of benchmarks. And then I will iterate over these 6 thread concurrency levels. I do some preamble. Here I configure the IO scheduler. Here I drop the caches to make the testing fair. So every test I do is going to start from the same clean slate. There is not going to be a cache that was generated by the previous run instance. This is important. Again, this will introduce bias, right? This will introduce an anomaly. Like the first test was very slow because it didn't have a cache, and the second test will be very fast because it already had the cache enabled. The cache warmed up. So to make sure all the tests are the same, we drop the caches in this case. In other cases, you might need to do other stuff, but what is important is clean up and make sure every test is starting from the same clean slate. Then I write some message. I have some human readable string that is going to help us understand what test is currently running in the bench. I was using PMM. I will show you in a minute. And PMM has this beautiful functionality, which is called annotate. And it allows me to introduce a marker in the graphs when there is an event. So I was using annotations to know in my graphs where one test started and the next one finished. So when one test finished and the next one started. And finally, I have my TPCC script, a bunch of connection parameters. Then I will start configuring the test. It's going to run for 1 hour. It's going to run with the number of threads. So this is one of the variables. And this was the other variable. Here it is. So this is this variable, right? Sysbench threads. And then tables is this variable. So I'm always running 100 tables. We determined that was a fair amount and that it will not introduce much variance in the benchmark. So it was fine. Then I'm taking 1 second interval reporting, which is going to allow me to create a nice graph of 1 second apart events if I want. Then Sysbench scale is the ratio at which things arrive to the database. And then I run, and again, I am careful of sending the output to a file that will later allow me to identify to which test it belonged. So I will keep my variable names attached to the file in some way, either inside the file or in the file name. I prefer the file name. You can do whatever you like. And that's it. This is the whole benchmark. And this benchmark was actually useful for us. So you can see it's not very hard, but it allowed us to build this plot. We took some notes. We were doing some IO scheduler investigation, so we took some notes. But here is the thing: is if we had the original PMM, which was destroyed months ago, I could hover those little orange triangles at the bottom, and they will show me this text. It will show me which how many threads is running and with what IO scheduler. But because I know the order MQ deadline, Kyber, BFQ, none. And I can very clearly see the groups. It's easy to tell that this was deadline, Kyber, BFQ, and none. And the y-axis is the latency. So lower, better. And we can see we have a clear winner. Like, there is a very clear winner, which is deadline. At some point, none was showing good results, but it quickly went up. We arrived to some, like, back then we were investigating why this changed it. I recall who was doing it with me. Well, I can't remember right now. It was months ago, but he arrived to some conclusion on why we never got to publish this. Like, it was sadly abandoned due to lack of time. But again, it was useful because we were able to tell, if you're running on Amazon EBS volumes, deadline shows consistently better performance for reads and for writes. And they are more reliable in the sense that there is no lots of variance, right? Like, you can see it's very the dots are very compressed, meaning that there is not much variance between requests. This shows somewhat better performance on some, but it's not truly, it's too scattered. So sometimes it's very good, sometimes it's not so good or really bad. And, again, this allow us to reach conclusions like, okay, if I'm going to have more than 256 threads, then perhaps, I want to stay with none, which looked more stable overall after a lot of threads. This looked very good up to 128 threads, but after that, it was no longer good. With none, it continued to have the same latency as it had with 128 threads. So, we can arrive to that kind of conclusions and take decisions on how to configure our instances based on this. We also took the throughput, the disk throughput, to compare, and we can see that disk throughput was brutally higher with MQ deadline up to 256 threads, where it literally died. None was never as good, but it never died as badly. So again, it's more stable for very high thread count. And then we also measured the MySQL throughput to understand how MySQL behaved with the different schedulers and different thread concurrencies. So this is like classic example of a simple micro benchmark to help us understand IO scheduler performance in MySQL with different concurrencies. And let me show you another simple testing I wrote for some customer. So a customer came and asked me, how do I test my IO? I was like, well, you could craft some sysbench lines that will be similar to your IO. And so what I did is I used it, again, very simple. First of all, I used the file IO test in sysbench. I said, okay, I want to test files of 256 gigs. I'm always going to be running, I prepared the test with 8 threads, and I said, I want to split this 256 gigs in 64 files. I'm going to use blocks of 16 kilobytes for this test because that's what InnoDB uses for vast majority of its operations. So I focused on that size, and I run the prepare. And after I have my prepare running, I will again do a very simple loop. In this case, I'm just going to test the number of threads, and I'm always going to stick to the rest of the variables. It's going to be always the same. And I carefully crafted the settings in, again, the test mode, the read-write ratio, the IO mode, how much asynchronous backlog, the extra flags. So all this is crafted in a way that reflected reality for the customer. You know, if I would have set this to 1, I would have made the test much heavier, but it didn't reflected what the customer had, because in his settings, he was not doing fsync all the time. It was just letting the OS take care of when to do fsync. So I did the same here. So again, this is not a universal testing for IO. It's rather an IO test I crafted for an individual customer, looking at his own settings. You know, so depending on your settings, you will adjust differently. And here I have a reasonable explanation of each of the settings, and I will share the links of these documents in a minute with Carlos. So with Mario, sorry. So he can post them later on our blog. But basically, I don't want to set a limit on the number of requests. I will be changing the number of threads, because this will change on any system. As the day goes by, you're going to have different number of people working on MySQL. Okay, how often I want to print metrics. This was about the size of this guy's database. The guy has a 200 gigabytes database. I use a 256 just to make it a round number. And then, and also I added this note where, you know, if you have 2 terabytes of data, but you only ever read 200 gigabytes, you could as well test with 200 gigabytes. You might as well test with the 2 terabytes. It's a good idea to also test with 2 terabytes. It's just going to make it far excruciatingly slower. Okay, number of files. Again, this was similar to number of tables they have. Then again, block size. This reflects the InnoDB default page size. We're going to do random. RN is random. RND is random, and RW is read-write. So we're going to be doing random read-writes, which is what you really want to test with a database, mostly, because again, you could go ahead, look at your PMM or your monitoring solution and characterize your workload so that you can better understand how much of your read workload is sequential and how much of your read workload is random, and also for the writes. So once you understand that, you can tune this better. Again, random IO is the problematic thing in IO. So I tend to test random IO first, or mostly. Then the ratio of reads to writes. So, you know, like how many reads am I going to do for every write? And I'm going to do like almost 2 reads for every write, give or take a bit less. Again, we took this number by dividing InnoDB rows read by the number of InnoDB rows inserted, delete, update. And, you know, we just, that's not a perfect number. We could have used pages read and pages written. That's also fair. Again, well, here I suggest InnoDB data read and InnoDB data written. But you have to characterize your workload to understand what's an appropriate ratio that will reflect your reality. Then
Marco,
InnoDB. Yep.
yeah, there are two more questions.
All right.
Yeah. How often should benchmarking be checked on an application? And the other one, what would the recommended frequency be?
So it looks like the same question. So frequency and how often is the same in my mind. So how often? Well, whenever you're about to do changes. I mean, if you benchmark, again, is to compare. Remember, benchmark is comparing. So if you have something to compare, you want to do a benchmark. Like, okay, you say, I'm going to upgrade my operative system. There you should run a benchmark. I'm going to upgrade my database. You know, especially if you're going to upgrade a major version upgrade, like from 5.7 to 8.0, then you should run a benchmark. Or, you know, I tell you, oh, look, you're having IO problems. You know, like you have some IO difficulties. You should use these settings. And you don't trust me, or you know, you're super concerned about effect of changes in the settings, or you have a changes committee that demands proof that the change is a good idea, then you will do a benchmark. And, you know, you will create a comparison. You will compare between your current production instance and the instance with the change. So, you know, you will check with an upgraded OS, you will check with the upgraded MySQL, or you will check with the changed setting. And I don't see the purpose of running any more often than when you need to compare things. I think that is the only time when you need to run benchmarks. Oops. So I was saying, again, I used InnoDB. InnoDB uses AIO, asynchronous IO. So I set IO mode asynchronous. And this is the default queue depth. And I'm just putting it here for completeness. But so if you want to tune this, you also need to tune the queue for your block device. And then we normally run InnoDB with ODirect, InnoDB flash method ODirect. So if you have that set, you also want to have extra flags equals direct. So again, you can see how I am trying to look at InnoDB to tune my benchmark so it more closely reflects reality. And then again, if you have InnoDB flash method equal InnoDB flash log at TRX commit equals 0, you probably want to do this equal 0. If you have InnoDB flash log at TRX commit equals 1, then you should make this 1. And well, finally, just run. And that was for table. You know, if I want to test my table, but InnoDB does other types of IO. For example, the IO it does for the redo log is very different. It's done in blocks of 512 bytes. And it's always sequential writes. It's always, if you use ODirect all, then you can use direct here. Otherwise, you should not use any extra flags. And again, how often we sync, and, you know, again, do it every time because we have this. So for the different and for binary logging, again, I did 1K. I'm going to do sequential writes. It's going to be, this should be removed because binary logs don't have direct. And if you have sync bin log equals 1, you should again use fsync frequency equals 1. So I'm in every case, like I'm reusing most of the stuff, but with small variations, I can emulate other parts of InnoDB. of MySQL. So again, this is just an example of how I will craft a sysbench to do some micro benchmarking. And with that, I conclude my presentation. Not sure if you guys have questions or anything else that you want me to show you or answer. If not, we can wrap up around here. I will share my links with Mario, who will later publish them.
Okay.
So you can find them later on our website. If you find this useful, we are here every other Friday. And I'm not sure what's our next topic, Mario.
Let me check. I'm not sure
I don't
if
remember.
I have the information. Yeah, let me check.
Yeah.
From our first questions, the one related with, how to keep the database running while doing an upgrade to MySQL. Could you answer that?
Yeah, I can do that. So there is no zero downtime upgrades in MySQL. Unless you are using a cluster, a virtually synchronous cluster like Percona XtraDB cluster or Percona server with group replication. So an individual instance of MySQL cannot be upgraded without some downtime. If you want to keep at zero downtime or like very, very near zero downtime, you need to have a virtually synchronous cluster. If you have an asynchronous replication, you will also need some downtime to do a clean failover between the active primary and the replica. And at the time you do that failover, you need to induce some downtime to guarantee consistency. So again, the most important thing to do zero downtime upgrades is to have the appropriate clustering solution running. Once you have the clustering solution with a virtually synchronous replication solution, you can just point the writes to any of the nodes, because all the nodes can take writes and be certified to be free of conflicts. So you don't need to take downtime to move the writes from one node to the other. And then you just, upgrade one node, like the other two nodes will still be taking writes. And once you're done with that upgrade, you can move to the next node. And finally, when you're going to upgrade the last node, you move the traffic to one of the already upgraded nodes. And that's it. Like, you don't have to suffer any downtime, but there is a solid requirement, which is that you must have a virtually synchronous replication solution in place. I hope that answers your question.
Okay. Well, our next stream will be on November 11, and the topic is how to secure MySQL.
Oh, I'm not sure that's my specialty. I'm not a security guy, but I know MySQL enough, so I will help you with that part. And yes, there are dozens of, I see a question, which is if there are any job positions available at Percona. There are plenty of them, including in our support department. I can tell you support at Percona is not the classic call center support that does things by the manual. And we have percona.com/careers. You will find all the open positions there, including their geographical location and an apply button. So please go there and check if you want to join us. And I'm not sure. I don't see any other questions.
No, I think that was the last one. There are no other questions in the comments.
All right. Okay, gentlemen, was a pleasure, and I'll see you November 11. Have a good one, everybody.
Thanks, everybody, for joining us. Thank you, Marcos, for all you have to share today, and see you next time.
See you next time. Bye bye.